Hi everyone, my name is Haley Metzger, and this week I'll be explaining problem number 4, which is the dolphin problem on the expert TA homework over 1D kinematics. So this problem states, a dolphin in an aquatic show jumps straight up out of the water at a velocity of 10.5 meters per second. Part A is how high does his body rise above the water in meters, and part B is how long is the dolphin in the air in seconds. So in order to understand this problem a little more, it's important to draw a picture. So here's the dolphin, here's the water, and then this is the path that the dolphin's taking when it jumps out of the water. So it's starting at an initial position of 0 meters, which is the y naught, and then its initial velocity is going to be 10.5 meters per second. Its acceleration is negative 9.8 meters per second squared. That's a number that we always know. We're looking for time, and we're looking for its height, its position here. And then we know that the velocity at its max height is 0 meters per second because that is where the direction is changing. So now that we have the picture, we can look at the formulas that use these variables. So for part A, we're looking at how high the body rises above the water, which is y. So we can use the equation y equals y naught plus v naught times t plus 1/2 at squared. And then for part B, we're looking for how long the dolphin is in the air in seconds. So we can use this equation v equals v naught plus at and rearrange it to solve for t, which ends up being t equals v minus v naught divided by a. So now that we have those equations, we can start doing the calculations. So for part A, we're solving for y, but you'll notice that we need this t variable to solve for y. So we're going to use the equation for t equals v minus v naught divided by a. And when plugging in our variables, we get t equals 0 meters per second minus 10.5 meters per second divided by negative 9.8 meters per second squared. When you solve that, it comes out to be t equals 1.07 seconds, which is the time it takes for the dolphin to get to its maximum height. Now that we have that, we can solve for y. And when you plug in all of the variables into this y equation, you get y equals 0 meters plus 10.5 meters per second times 1.07 seconds plus 1/2 times negative 9.8 meters per second squared times 1.07 seconds squared. And when you solve for y, you end up getting y equals 5.625 meters. So the dolphin's maximum height is going to be 5.625 meters. And then for part B, we're solving for the time that the dolphin is in the air in seconds. So you'll remember that we just solved for time, but we were solving for time it takes for the dolphin to get to the maximum height. So in order to get total time, you're going to do that 1.07 seconds times 2 to account for the dolphin going all the way up and then back down. So when you do that, you're going to get the total time equals 2.14 seconds. And some important things to remember when solving this problem is remembering to multiply this time by 2 to account for the dolphin going up and back down, rather than just saying that the time the dolphin is in the air is 1.07 seconds, because that would not be correct. And then also recognizing that this velocity is going to be 0 meters per second, because that is when the dolphin is reaching its maximum height. It's stopping before changing directions. So remembering that this is 0 meters per second. And I hope that this video helped you understand the problem a little bit more. Thank you.